the subject of my speech is something unexpected. We can name this like joint interdepartmental interaction in solving the task of sustainable land use and management in Moscow region. This project is in progress now. It starts about 1.5 years with this order. Our Ministry of Agriculture of Moscow region issued an order to have a passport of fertility for each cadastral unit. It was about 1.5 years ago, and then we start. 25th of December in 2017 year. We faced with such problem. To make a passport, we need a lot of information that is usually collected in various departments. Moreover, not only in departments of Moscow region government, but also in state government and in educational organizations like Moscow State University. A little about this region. You see, this region is about 8 million hectares in whole, and it has about 3 million hectares only in agriculture use. So what we have before that time, we have only paper soil maps of this region. We have a comparatively big history of agricultural fertility monitoring in some paper and in Excel tables, or maybe some in Access tables. And we had map of fields of this region. I mean Moscow State University. Also, the agrochemical center of state has all this data, of course, and it has no at all map of land use, and it has no the map of cadastral map. But their legacy contains large-scale soil maps and data of surveys. Well, the common view of our goal is something like that. Each cadastral passport should contain about 6 pages, and for example, usual landowner has from 10 cadastral numbers, cadastral parcels, up to several hundreds of cadastral. And about 3.5 million of cadastral numbers there is on the territory of Moscow region. So about 1 hectare for 1 cadastral parcel. So, for example, if you consider usual landowner, then he must have about 100 cadastral numbers, about 600 pages printed in from Word file. So very, very big and time-consuming work. Besides these layers I listed, we need soil map, small scale, middle scale, 1 to 300,000 scale. We need field map, we need cadastral map, we need soil use map, and also we need data from soil fertility monitoring. We need a map of various negative processes, including as natural negative process and artificial human-induced negative processes like garbage, like open mine, like artificial lakes, and so on. In this picture, I showed you that State Government Agrochemical Center has one part of information. Second, department from Moscow region government has land use maps and cadastral maps. Another department from Moscow region government has data about crops and yields, and moreover, this is main profit from this system, because this department is responsible for investment, for future planning, and in future planning in this area future planning also includes returning abandoned lands into agriculture use. About 60,000 hectares per year we must return in agriculture use. Well, so we have at least 4 participants in this project. Officially, this project started on the 4th February this year, officially. Before that time, we had a vectorized soil map of this region, middle scale soil map, middle scale. Of course, it is not enough, but we can, I'll show, we can compose our decisions based on similarity of various regions. We have, of course, field map. We have at least 3 map of soil, of land use, at least 3 map, because each year this big region is constantly changed, and we make an agreement inside that we permit to change land use map only 1 time per year. Of course, and one department is responsible for constant refining this map. Next, cadastral map. Of course, about 10% of our land use is changed every year, because ownership of some part of land may change ownership, change lease on ownership on rent on this various right on this land. So about 10% every year is changed. And moreover, Moscow region has very high density of population, and this population is constantly growing and expanding in building, construction, and so on. So you can find, for example, you analyze the field and its history, and you found that on this field is a little village or something else. So, because of various departments, we make a decision to construct distributed network on which this work can be implemented. And here I invoked some distant application, some distant sources of this work to show you how it organized, real, and how it can work in real time and real life. Well, so this work started about 3 months ago, and we have about 1 month to finish this work. And about 1 month ago, we have made an intermediate report in government, Moscow region government, and this intermediate report consisted from these 6 steps, what we have made and what we are going to present in the ending of this project. The first is registry. We should make inventarization of all informational resources and make typical properties of soil, typical names of layers, and all this layer you can see on the, for example, this attribute table for soil, large-scale soil map, and here we can see the titles, typical titles, and soil description is divided on two main taxons according to our national soil classification 1977. And I think this soil classification is very similar to former Myanmar soil classification. Well, but of course we need more detailed soil map, at least with the scale 1 to 5,000, 5 to 25,000, to make a decision. And so it is not our capacity to vectorize in one short time period to vectorize all this map. How we made this in our project. We took the soil and agricultural natural regions of for this region. This region can be divided into 5 parts, and moreover, according to soil, landscape, relief, and so on. Moreover, each part can be divided into more little part, and you can see that these parts here. Well, we also have all set of soil maps of this region. I can show you this. I'm using ArcGIS and QGIS for this presentation. So you can see here we have good enough cover of all region. But this is map only for borders of estates, only borders, not soil maps, large-scale soil maps. But after dividing all region into five zones, we take 1-2 representative estates with soil maps, and then we vectorized them. Moreover, we not only vectorized them, but we analyzed all legend of all about 500 estates. We compose list of soil description, divided, eliminated, deleted all repeated soil description, soil names, then divided this soil description into separate words. We name each column of this table according to soil classification, and then we get a list, short list, for each taxon unit. So, well, this is the base for future vectorization of all this region. We calculated approximately time that we need to make this work. It's about 10 person year. 10 person 1 year, 1 person 10 year. Really, we have only 5 people who can do this work with sufficient qualification. Also, we made methodological support because we must provide our customers, these departments, with ability to improve these maps, to correct, and so on. So we made methodics, books, and we developed a program for education about 2 weeks, 42 hours in classroom and about 70 hours in homework. And we made this vectorization. I can show you. Let me show on this example. This is a QGIS system, and for example, you see these estates are located in 5 different regions, and if we take this, so this estate, then we can show you source map of this source map. This source map was composed from 4 paper layers, and under this georeferenced layer we put this layer. You see, this is a digital elevation model, and of course we put under this map the middle scale soil map we made before. And we have a corresponding legend, a corresponding attribute table for middle scale and for large scale soil maps. The next, we should list about 7 layers at all. And some layers are specific for this region. For example, I can show here the negative layers. Negative layer, and this negative layer has corresponding attribute table. Here is a marsh or bog. There is an erosion area. There is area with garbage. There is an area with bad relief, complex relief organization, area with lakes, and area with very, very big problem for this region is a weed growing. There is simple. There is several type of weed that are very harmful for man, and it has very long time, about 12 years in the ground. So this is one negative factor. Also, we need land use map. Land use map, and in this land use we can name such type of land using as arable land, pasture, hayfields, gardens, and free lands. And as you can see, we have a comparatively complex view of this map, but it is special department of land using, and if we can transfer this vector map on the Google Earth, you can see that in gaps we will see either roads, either some technical construction or homes and so on. And well, next I can show you a cadastral map for this region. For example, so I think it is enough to understand how complex this is. Each this part is separate cadastral number, and from very, very little to very big, with holes, with gaps, and so on. So, and it is not necessary that land use map and cadastral map should be considered. They are not the same map. So during the forming cadastral passport, 6 pages document, we should make passport for one cadastre. Inside this cadastre there is maybe several land use units. There is possibility to have several soil units, and of course several field. And when we are talking about database, all these objects are different, and all this object contains and store its own information. For example, I can show you the information from soil fields. This is soil fields, and these fields are the object that should be observed at least one time per 5 years. And the attribute table of this field contains such columns like numbered columns 1, 2, 3, and so on. Why? So, in this point, I'd like to go in more deep into database organization. Really, we proved, at least for ourselves, that it is impossible to make decision without computer support. And computer support does not mean using GIS for making decision. It's not human possibility to intersect 7 layers with such kind of complexity and to make decision with calculating areas and so other properties. For example, I can show you part of our methodics, how we can calculate influence of various negative parameters for cadastral passport. You see this very simple demonstration of overlaying several layers with negative factors, with land use map, with cadastral map, with field, with soil map. And here is several rules. Of course, nobody can do this. Oh, maybe. If you have a lot of time, if you have big monitor or tool, of course you can make a proper right decision for certain cadastral unit, of course. But if you have 100 such units, it is time-consuming operation. And of course, if you are owner of this estate, you can't do this without help of high-skilled personnel. So it's only question of time and money, really. So in that case, we decided about 8 years ago to organize a database. And this database looks like so. Well, this is a simple list of properly organized tables. These tables are related to each other in certain, for example, manner. Related, I mean, we're working now with distant agrochemical center. you can see the address of this agrochemical center. You see this data center point soil point mcu point ru slash gis so it's slightly differs maybe from you used to see because it's a direct communication from one database server to another database server. Direct communication via internet, of course, but not via HTML protocol or something else. So we have tables. Tables are divided into semantic, according to its semantic, divided into vocabularies, alphanumeric data, geographical data, and temporal tables, various temporal tables. And of course, the main advantage of SQL Server is possibility to implement some operation, some task on this server. So we can make all geographical operation in the cloud, really. And now I can explain what means title of tables in this attribute table. You remember the attribute table for field. These numbers 1, 2, 3, and so on means number in this table. So this table names the list of agrochemical properties. So really, this is a standard for our data center. And this standard is valid for all agrochemical center we are working with. And number, name of property, maximum and minimum number for input filtration, measurement unit, and the method of measurement or measurement and extraction. So this is something like standard. Well, so now I have listed almost all layers, and we can go to the next problem. If we have enough information for each point, of course we can compose algorithm for computer to calculate something you need, of course. But as usual in soil science, there is not enough information in most time we working with. And in this case, we are working with similarity. So if we have no enough information in large scale soil map, we can put point from the middle scale map. If we have no agrochemical data for this field, but this field is similar the adjacent neighbor field with known characteristics, we can transfer data from one point to another, from one field to another field, from one land use map unit to another. So we are using mainly similarity principle in solving such problem. Of course, when we are calculating the soil organic carbon map, of course we are using more complex algorithms, including interpolation, including regression equations, and so on. But when we need simple, comparatively simple cadastral passport, we use the principle of similarity. I showed you the database server. Of course, end user can't work with SQL Server. What kind of informational resources can use usual land researcher, agriculture researcher, so on. So, because this system, of course, is oriented on GIS departments of regional agrochemical centers.
Can I interrupt here?
Of course.
So now we learn from you that we have to link or interact with land use map and also the agrochemical map. So the analysis data from the agrochemical section and cadastral map. And in our country, we have working group from YAU, DOE, land use, and also the land management and statistics. They have a cadastral map. And in the morning, we heard about that. There we also needed the irrigation map. But in our working group, there is no one from the irrigation department. We also, irrigation department have some mapping about the irrigation and some other thing, and also the forest department, they have also the GIS mapping for the forestry and other land. So, but in our group, forest department, the staff from the forest department is now not included right now, and also we did not consider about the irrigation staff in our working group. If it is also needed in our working group, we would like to request to our DD, to request to the irrigation department to participate in our working group. So now, how about in your country the responsibility of the irrigation department? Thank you.
Thank you, dear Susu. I almost forgot some layers, and it is very important. Your question is very important for me because the title of my speech is Achievement of Interdepartment Interaction. Yeah. So really, I almost forgot about another two layers. Of course, we had irrigation layer, and this irrigation layer goes from this department. This department.
So irrigation.
They are responsible, and we have now two irrigation layers in our database. Moreover, one of the complex negative problems in our region is forest growing on arable lands. So we have another layer that was calculated from satellite image in our university. But after that, this layer was vectorized, and during usual every year observation from this department, State Department, they having our preliminary forest map, they can find this map during their observation. Of course, it's a very, very important question. And I'd like to show you our irrigation map. And for example, here you see we have melioration 2018 and melioration before in former Soviet Union, before 1990. Yeah. So we have at least 3 melioration map, of course. And we have a forest map, it's G_forest. It's not readable. And I'd like to show these maps on GIS system. For example, this is a forest map, and it's overlaid with fields. The main question is how we can organize interaction with these departments. And now I can really this is very big, of course, work, you understand. And I can talk about this 1, 2, 3, 4, 5 days. But I must list all points. And now the point is how can use this system usual agrochemical specialist. For example, if this person work under QGIS, he can connect, you see, with one or several data center online, and get a list of possible alphanumerical and geographical layers. Alphanumerical mean vocabularies, some numbers and so on, and geographical, I mean layers of your system. And moreover, you can you have a choice, possibility to choose part of this layer, of course, because this layer is very big, and you can choose only one type of soil, oil of land management, or only one type of negative process, and so on. I can show all this well, and this possibility is for agrochemical center, state agrochemical center, almost all state agrochemical center. But it is not suitable for regional government. For regional government, we use another standard for data transfer. This is well-known WFS standard. Maybe somebody know this and use this. I know that in Thailand your informational institute use this standard. This standard looks like this WFS and web feature service. So this is a service that permits to interchange with vector information. And here we can connect directly to government of Moscow region. And we can see melioration, irrigation layer. We can see land use map old. We can use human impacted area of agricultural lands, and we can see all land use map. So, and the cadastral map is not listed here, but it is also goes from this source. Fine. So, the user of GIS system can get information from various sources into his computer. The second question is how you can place your information, your shape file or Excel table into database. I can show you the start part of this. We are usually doing this from ArcGIS. You have data interoperability tool, and after invoking this interoperability tool, you can export your shape file into database. Moreover, you can export your shape file in one database, second, another, in Australia, in North Pole, and everywhere. But usually, the organization of work assumed that you have your local network of your organization, and you have server, and this server has limited connection to world, and you are working inside your organization. All this possible, of course, on the local network. And only if you want to exchange with other departments or other countries, you can make special channel for this exchanging. Well, but of course, this possibility to communicate between GIS system and soil databases in various ways, of course, it is very, very powerful tool. But this tool requires big capacity and very skilled personnel. Because of that, we made something like end user interface. End user interface that looks like, I can show you. Well, this is a typical user interface for various soil data centers. I can fine-tune by choosing this. For example, here we can see 5 data centers. I'll magnify this screen. Well, 1, 2, 3, 4. I have 5 different data center, and I can switch from one data center to another. But all they have similar user interface, similar organization of database structure, and almost similar way of using. When you have, for example, let us try this part. This part is named tools. We can control temporal tables. It's not it is far enough from our country because it is not instant reaction on my click. So if you want to upload Excel table with certain standard title head, you can just click there, choose the table, then upload, send, and that's it. If you are working with geographical information, of course, it's a more complex information, and not we must place the separation of access, and not every user has rights to upload geographical information, because geographical information is very, very sensitive. And you can upload your geographical information from ArcGIS to temporal table, and then if you want, you can overlay this geographical information by clicking temporal table and corresponding permanent table. And during this overlaying, you can delete previous borders if you consider these borders are wrong. Either you can add another borders in this table because it is another year, and we must store all history of these borders. And this is true for each geographical object, maybe excepting points, because points is usual way we always add this point. Well, then I can show you how we can work with this information. For example, we have a set of typical function under these buttons. And of course, each agrochemical center is maybe similar, but this is different. And task that usually each agrochemical center differs from one to another. And of course, this names like XXX for future development, for future work. But the organization for all agrochemical center is the same. So we can separate tools from reports. You know, each official organization has a way headache about reports, statistics, and so on. At least in our country, all GIS specialists are constantly busy with preparing various reports and so on. I hope you are more happy in this case, but maybe. So, the second part of, very main part of this user interface is reports. For example, we can use agrochemical passport for estate. This is not cadastral passport. It's only simple agrochemical passport. For example, you see, this is a region about 6,000 kilometers. So we can wait a little, and I hope we can get something like this. Fields and properties. You see humus content, potassium, magnesium, boron, pH, phosphorus, and so on. And this somewhere we can undefined places. So online composing of various reports, and this is for one data center. And for example, here we can see another data center, for example, and here we can see various applications. Applications is, for example, fertilization. You see this in mobile, our mobile application, and this work for certain region, and works with all possible layers for this region. So let me summarize that you can communicate with soil databases in various ways. One way is direct control of soil data server. It's upper level of qualification, of course, and elaborating of certain program application, certain structures, and so on. The second layer is for GIS specialists from agrochemical centers, for soil researchers, and we are working on education on this manner with our students. We have about 4 or 5 educational databases, and we are working with students. We used to give them all information about certain estate, and they must compose agrochemical passport. One more, specialist can communicate not only direct to SQL server, database server, but also it communicate with WFS server. The main thing is standardization. So we must operate with the same vocabulary, with the same measurement units, with the same methods. And the third level is usual way for everyday work. If you are working in standardized environment, I mean under standardized environment, a set of internal rules, a set of internal posters with Excel tables, heads. I mean posters with rules of what we mean under this term or another term. So if you are working in standardized environment, we can work very, very helpful. So, and I'd like to finish with this presentation, and The last but not least, our step is to prepare methodological books, programs, and education, because our capacity is not enough, really, to implement all work for only one region, because we very small team, but we constantly work in cooperation with agrochemical center of our country. We constantly have a workshop, additional educational program, and so on, so we can slightly expand our knowledge to other region and even more on countries of Eurasian soil partnership. So, well, this was not more a lot of question, but I tried to list shortly all points how this project works, and really from start working with this subject on Moscow region, and now only 1.5 years. Only. And it is really our achievements, because work of our, very intensive work of our team consists with main thing, with wishing of governmental structures, governmental persons, and from skilled personnel from GIS laboratories. So our team are GIS specialists from institute or GIS departments, and heads of Ministry of corresponding department of government is key to solve the problem. Thank you very much.